So here we have four unknowns: the acceleration of the center of mass in the horizontal direction, acceleration of the center of mass in the vertical direction, the angular acceleration, and then the normal reaction at point A, with the understanding that the normal reaction at point D is equal to 0. Now we have four unknowns, but we have only three equations here, 1, 2, and 3. But so we need one more equation to be able to solve for all four unknowns. Where do we get that equation from? It again has to do with kinematics, in other words, some assumption about how the object is moving. And what we have stated is that our sort of assumption, if you will, is that this object, this point on the object is in contact with the ground, but this point has just left contact so that the normal reaction is equal to 0. So what's happening is that this point is scooting along the ground, moving along the ground like so, whereas this point is starting to take off. So there's an angular acceleration, but this point itself is moving horizontally because it retains contact with the ground. So you should look up, if you have not seen videos of wheelies, you should look up YouTube videos of wheelies. So that's what happens in a wheelie, where the rearmost point is in contact with the ground, whereas the foremost point sort of takes off. Okay, so the kinematic condition, in other words, an assumption about the motion of the object, has to do with this point A, and we can essentially say that the vertical component, so the extra equation, is that acceleration of point A is only along I and has 0 component along J. So how do we get that equation? So we can actually write an expression like our old previous homework, AA equals AG plus, it's sort of unfortunate that we started using this symbol W for the width, but I guess we also have this omega. This is omega, so let me actually go minus omega square r A with respect to G plus alpha K cross R A with respect to G. Initially, when the object is just taking off, the angular velocity equals 0, even though the angular acceleration equals 0. So we can sort of cross that out. So what we have is AGX I plus AGY J, that's AG, and that's what we've assumed here now to be the acceleration state of the system, plus alpha K. And RA with respect to G is essentially this vector from G to A. A is minus W over 2 in the I direction and minus H over 2 in the J direction. So so that's AA. Let's simplify that. Alpha K, K cross I is J, and we have minus alpha W by 2 J, and then K cross J is minus I, and we have minus H alpha over 2 minus I. Okay, so let's simplify that further. We can collect all the I terms. The I terms give you AGX plus H alpha by 2, and then the J terms is AGY minus alpha omega over 2. Okay, And the condition, the extra equation that we get, is that the acceleration of point A is only along the x direction, not along the y direction. So not along the y direction, AA, only along I, and not along J implies set J component to 0. So we have AG y minus alpha w by 2 equals 0, or AGY equals alpha w by 2. And that's your equation number 4. Okay, so we have now 4 equations in the 4 unknowns. Equation number 1, 2, 3, and this is the 4th equation, which you can then solve for acceleration of the center of mass in the x direction, y direction, the angular acceleration, and then the normal reaction at A. So that's how you would solve the problem if you allowed for the fact that the object is doing a wheelie, which means that this point is scooting along the ground horizontally, this point is taking off just barely, and there is linear acceleration for the center of mass in both the x and y directions, and then there is angular acceleration. So that's what happens when the force, the horizontal force, is very, very large. So that's how we would solve the problem for F equals 100,000, right? So when we plugged in F equals 100,000 in the original equations, which assumed that the object was moving without rotation, you got a negative normal reaction, and then we set the normal reaction to 0, and then solve for, redid the whole problem in some sense. Okay, so the second part where we are doing the wheelie problem is would be considered more advanced probably in the context of this course. But we might ask you sort of problems like where, okay, for what force does the normal reaction just go to 0 or something? Where does, when does this point start to lose contact, at what force? That might be a question, for instance. And if we ask a question like this in the context of an exam, we will explicitly outline like what assumptions to make typically, where we will say, hey, assume that the object is moving horizontally without rotating, or assume in this case that the object is moving in a manner that A moves horizontally, but other points have both horizontal and vertical accelerations, or something like that. So we will make those assumptions explicit. In this particular example, I sort of try to motivate how those assumptions arise. But in the context of exam, if we do ask a question like this, we will make sure that you know what the assumptions are. Something else I did not state explicitly, but I've sort of assumed implicitly, is that there is no friction at A and D. F is actually an applied force, right? It's not friction; it's an applied force. It's like if you're imagining this to be a car, it's like the anyway. Implicitly, well, it's going to be friction, but in any case, for the purposes of this problem, just imagine someone pushing a block with a very large force at A. Okay. Of course, you can modify the problem to include friction, and you're just going to have friction forces here. Here, if you do have friction, then you can assume that the friction is going to be equal to mu times n A or mu times n D, because those points are slipping, right? So for part A, when we assume that this object is moving horizontally without any rotation, we can, if there is friction, you can assume that it's a friction force here, which is mu k times na, friction force here, which is mu k times nd, because it is slip. There is kinetic friction. It's not rolling without slip or anything like that. There is actual slip, so you can assume that it's mu k times n. Okay, so let's stop there for this problem.